So I'm Igor, I'm principal engineer at Skyscanner. Before Skyscanner, I worked in a fintech here in London for 5 years almost. And before that, I've been working as an engineer, and I went up the ladder up to a CTO in various businesses, from digital consultancies to internet service providers, hosting providers, web agencies, whatever. A few fun things you might want to know about me. I set up my first Linux server when I was 13, and that was like a website, and it was a Quake 2 server, to be honest, running on high school internet broadband, but that was pretty fun. I had a 19-inch rack in my flat, and that was like a purpose-built space in the flat to host all the fun projects I was working on at the time. And I still have quite a good portion of IPv4 IP addresses on the internet, which is a bit rare these days. But let's talk about microservices. Oh, sure. Sure I can. Is it better? Yeah. Yes. Cool. Thank you. So, well, it all started with a monolith. Quite a long time ago, when I just stepped up into this world of modern internet architecture, what I saw was a big, ugly box. It had lots of stuff in it, lots of different functions, features, pieces of code. Some of them were fancy, some of them were not that fancy, and it was complicated. And what happens if this thing just blows up? Well, traditional answer for this, you go and you read logs. That's how it's kind of done for generations, I suppose, these days. But what if we're in the year, I actually said 2019, but we're in 2020 now, and we now have not one microservice, we have, well, let's say 5. So what happens if one of those blows up? Well, you might want to say that, okay, we're gonna go and read logs, but what if it's 2? Can you be that fast to go and read logs? Can you be that fast to keep up with those 2 services going, well, nuts generally, and you have no clue what's going on? Well, you can say, yeah, I can. I can do it that fast. I can read logs super fast. I can just go and read every line because I do that every day. But what if you have 50 services? That becomes a bit unmanageable. And then what if you have a 500? That's not possible, humanly possible. And coming out of that, we then come to the modern world of nicely enabled services with lots of different things going on. It's all built nicely and it works well. Well, and then we have that magic thing which is called observability, which is a combination of your metrics, your logs, and your traces. And if you've done everything right, there in the very middle you're going to have your perfect spot of full observability, which is going to give you full transparency of what's going on in your stack, and you're going to be super happy about that. Is that really possible? Well, depends. In an ideal world, I suppose you're going to get, well, just 2 of those, as usual. But you might have most of them right, and that's going to give you a huge advantage in investigating problems and generally going the right way to see problems at a glance and fast. And let's come back to where I was a few years ago. So I had this thing, which was, well, it was a box. Really, because it's hard to tell a story about something which is, well, it's actually this. It's an app which produces some cool big bowl of spaghetti. And it doesn't have any tracing, it doesn't have any monitoring, it's just logs. And from that specific app I had some time ago, there were logs produced in both JSON and text. And this was unmanageable overall because you're going to have some logs structured, which you can search for, and then some logs which are just dropping out as, like a pile of random text, not very well handled, and you have no idea how to handle that. And in that specific platform, we also had it delivered synchronously over TCP to a third-party service, meaning that it did slow down like every request it wanted to generate a log line on. It was just unmanageable. So as an example, like where to go from here, and that was a pretty small stack of like that scale of 50 probably services. So what we did is we was like a larger piece of work going on with where do we go from set of programming languages and frameworks we were in at that time. And well, we went for Golang, which was quite unusual at that time. It was quite new and not too many companies did that. It was like in pre-Monzo era, where it was not that known for using Golang in applications. It was even probably wide usage of Kubernetes at that time. So there was an app, and there was a framework built in Go which abstracted all these login problems into a nice libraries, and it gave engineers who build those microservices power to just write 2 lines of code, and send that log line somewhere. It sounds easy, yeah? I mean, what could be easier than just send a log line, but what about doing it in a very predefined structure? What about defining that structure and maintaining it over a set of, 50 services maintained by different people or different teams? Then how do we make sure that we add a set of standard tags to every log message so we know where the problem happened every time with some guarantee, and then we can search for those log lines across our whatever system we're using. Let's say we're using Kibana to look at logs, and how do we make it searchable and we have confidence that we recorded every line from every service within a context. And what was good about that generation 2 type of system, that it was finally decoupled from the application itself, so it allowed the app to just dump logs into standard output, which was super fast because you're just sending them to console basically. And there was a good and bad thing that we then relied on a Docker driver to deliver those logs. The good thing about that was that, there wasn't much work required to make it happen. We all know that Docker has all sorts of log drivers you could use to deliver your logs somewhere. The particular problem with that solution is that if you don't have any kind of queuing system after Docker before logs reach your login system, then you are in risk of flooding your system. Either it's actually a Docker daemon, or it's going to be like Logstash in this case, just because you're going to produce too much logs. That system didn't have that problem just because it wasn't probably that scale to produce that many logs. And one more thing there was that it did run on pretty small nodes, because these days in the age of Istio, you would have huge Kubernetes nodes running 32, 64 gig of memory, and you're going to deploy all that sidecars, and you're going to have 4, 8 gig per container sometimes to run all of that. And you may need bigger nodes, and you want to have something in the middle to buffer those logs. In systems small enough, you don't need that. It's just going to work at some scale to some extent. And And that was like small and nice, and that's a small system. Here what Skyscanner data platform looks like. It's a bit more complicated. This particular screen describes both metric collection and log collection. So if you follow that from left to right, for logs, for example, it actually looks pretty much the same as the previous one. So there is, again, some kind of abstraction on a programming language level, which gives you an SDK to send log lines. Then there is some service which is responsible for log consumption. Then there is Kafka to stream those logs, and then there is Elasticsearch to store those logs, and there will be a Kibana to view them. The rest is more about metrics. Yeah, so if we send metrics, we send them the same way, but then we record them into OpenTSDB, and then we have Grafana to look at them and Boson to send alerts if we want to. Then there is like the whole data processing and data transformation to build different kind of reports, but it's probably kind of out of scope here. So if we talk about logging a bit, these are probably like summarize things we can talk about what makes a good login. Well, first of all, it has to be structured. So at least we're targeting to have some kind of common JSON schema defined. If we can do that in a different world, we probably would choose protobuf to send those log lines. Then we want to have defined data structure on top of those logs. So it's not just let's pack everything in JSON. And again, if you have more than probably even 5 services, you're going to end up with a problem that each service sends logs in a different format. And even if they're in JSON, given that power to define schema as teams wish to, it's just going to end up again a bit messy, just because it's going to be hard to find something. Then there is that schema, which also should include common context. So it's something about a specific request, so like a request ID. It's something about a session we are working in. It's something about if you are like in an e-commerce world, then you probably care about an order happening and you want to record that on every log message which relates to that order. So then you can say, just show me log lines by that order ID, and that's it. Simple. But then there is identity. So how do we find all logs by a user? Then there is release information. So how do we track every deployment and regression it causes to our stack? It's not just one application, it's a stack of services. And then there is platform again. So in which port is it running, for example, in which cluster, on which particular node. And doing that and writing that abstraction to collect all that information, pack it, and send it together with each log line, it's super empowering for every engineer and for every team responsible for that stack, because it allows like easily find problems. And again, within different areas of that stack, different responsibility and different capability. Then there is that decoupling. It's quite common to send logs from just an application, so we're going to connect somewhere and send those log lines. In a world of containers, you should expect that your container might just die. And that means that some log lines could be undelivered. And that means that you don't have the data to rely on to investigate a problem. And the problem may be, it's a good case if it was just killed by an orchestrator to rebalance. But what if it was some kind of a problem within the app and the app crashed, and it just couldn't send that log line in time. So decoupling that sending of logs from the app allows you to capture all those things up to the very last second of that container lifecycle. And then there is delivery. So how do we make it reliable? So it's not just about dumping logs into standard output. How do we then make sure that everything we dumped into standard output is being delivered? Again, what if the node dies on which we're collecting all of that? Can we write anything and accommodate somehow that possible crash of a node? And then there is the last one, which is like personal data. Well, it's a tricky one to get right because it's hard to automate, so it's properly scraped from every message we send, and we're always confident that we are not sending any personal data in log messages. So it usually becomes a collective responsibility of teams to make sure that we don't send any PII. But then there are interesting cases. What if it happens unintentionally by some underlying infrastructure, underlying libraries, and it just sends out? Then we get into, incident territory, and we try to understand and eliminate that impact of that personal information being logged somewhere. It's not an easy thing, but it's just something to consider and making sure that we address that when we log. Then there is completely different territory, which is metrics. So I'm just gonna kind of give out a few tips and practices and considerations which I encountered on my way. So one of them is push versus pull on building a monitoring system and metric collection. The traditional way would be to push metrics. That's how we're used to with the world of graphite, for example, and sending the via statsd, for example. That's okay, probably, but once you start scaling that to some significant volume, it creates quite a lot of overhead and things to consider. Again, how your application is built so it can deliver those metrics reliably, because what can happen, well, it's the same thing as decoupling logs, yeah? So we send that metric somewhere, it's not delivered because there is something down on the way, and that's it, and we'll lose metric collection. On the other hand, if we talk about pulling metrics, which probably one of the famous examples here is Prometheus, it creates that gap because of collection interval, and it's super cool for projects which do not want to build in that reliable transport into the application, but it's not that great for services which want granular and fast metric delivery. So it's just a consideration, like see which one are you. And then metrics are not just CPU and memory. So in my experience, when I talk to engineers, it's quite often thought that metric is like how much resources my application is consuming, and that's not just what we care about. So at least we need to look into application layer. So our app makes requests, it calls databases, it calls other services. Do we monitor how long does it take? Do we monitor what are the error codes of those responses? Do we monitor the data transfer volumes? Do we monitor how many Go routines or threads we have? What are our thread pool sizes are? How full are they? It's more than just like CPU is up 100%, let's scale. It does work that way, but probably just up to some extent, because there is always an underlying root cause. Then there is a wonderful world of business metrics. So orders, bookings, progression into the funnel, all sorts of things. And it's very important to monitor those. And when we set up alerts on different things, it's not just about our CPU going up or down, it's also our order volumes are going up or down, our contacts from our customers, submissions of different forms going up or down. And the last and the most important thing about metrics, they have to be actionable. It's the most standard, I want to say, failure in introducing monitoring into a new stack or into existing stack is that we say that we do monitor and tick. We deploy that, we set it up, and then we do nothing about it. So it just lies there somewhere, well, in a fancy case on the wall, on a telly, and showing some nice graphs. And that's as far as we go, So that all the metrics we introduce, business metrics, application metrics, platform metrics, they all have to be actionable, they all have to have thresholds, and we need to do something about them. But doing something about them meaning having a runbook. So when metric hits a threshold, we then trigger an alert, and that alert always has a link to a runbook which we follow to understand what happened. That doesn't sound like rocket science, but it's quite often forgotten, it's not like this. And then there is the last one, which is tracing. Well, this is, by the way, how Jaeger, one of tracing systems, look like. So shortly, if any of you, probably most of you, have seen how debug console in your browser look like. So you go there and you can see that these are my JavaScript files loaded, these are my HTML files loaded, these are my images loaded, and you can see that nice performance graph. So tracing gives you more or less the same, but across microservice stack. So you can see one service calling another service, calling a database, and recording that in a visual form for you to see. Why do we need that? Because it can give us visibility into network-related issues, into different kind of latency, whether it's API calls to other services or it's internal within the request. That was weird. Then there are, again, threads and Go routines or whatever concurrency model we're using, and this is a way for us to see that it's creating a spike of those. We can see that in tracing just visually because it's going to create lots of different requests. It also can give us some insight into memory leaks, again, because of that. Then there is a structured log inside of tracing. So if you remember that logs system, and imagine when we did that nice structured logging thing with the data structure defined. But if it's 50 services, it's 50 services. So if one call into your stack then creates a spread of another 20 calls somewhere, then this means that you have to read through quite a few log lines to understand what's happening. So here is our tracing giving you a way to see log line per call. Right here on this example. So this is another system called Lightstep, and this is the one we use in Skyscanner. And on the right here, you can see a log message attached to a specific call. So we are making a call from one service to another, and this is a log. For example, here it's like this example shows you a request payload for this specific call to that specific service. So rather than just reading through all the log lines of all services, you can just have that structured in one way. And then you can search using tags, and if you do it right, then you're going to have same tags in logs and metrics and monitoring. So you can search by your booking ID or your user ID across all three systems, and then you can say, okay, tracing system, show me all traces based on that order number on the funnel step number, something. And it's just going to give you, okay, these are all the requests, and these are all the log lines for that request structured. The thing about tracing is that because it's a microservice world, you want to automate it to be across multiple transports, meaning that you need to cover HTTP, you need to cover gRPC if you use one, you need to cover all sorts of message queues, you need to cover streams if you use them, you want to cover database calls, caches, even email delivery. So everything within your microservice stack is covered. All service calls between each other are covered. Because if you don't do this, then what happens is you're going to have one service calling another service, then another service, and then that last service doesn't have tracing enabled, or it doesn't record the tracing data. So even if you have 20 more services behind that one, you're going to have a black hole, so you're going to have a thing which sucks just everything, and you're going to have like that, well, dead end in your tracing. So it's very important when you enter that tracing adoption to actually work on that. My personal record so far was automating that tracing stack of around, well, it was definitely more than 20, but the longest trace I had was like 20 plus services with 1,000-ish spans in just one request. But that took a year to do. Then, practical lessons learned. Well, first of all, define standards. Standards help you being consistent. It is very important to not just to say that we need to send everything in JSON, or we need, yeah, or I'd rather just turn it off because, cool. So it's not just about defining data structure for logs, it's also about documenting the data structure somewhere so we all agree that we do it like this. And then there is another one. What if you have many programming languages? What if you don't have just one nice modern language or a framework? Then it becomes interesting. Standard will help you reach that consistency across your microservice stack in every programming language. But again, that requires effort to enforce that standard in that stack. Then there is selling the standard. We might talk about it in Q&A a bit more if we have time. So you want to find your early adopters, you want to find your stakeholders, you want to talk to them for them to help you for that standard, well, to live, not just be some document dying in conference somewhere. Then there is an abstraction. So, and again, it's abstractions because you're going to have as many abstractions as many programming languages you have. So those have to be built in every language, and that takes time as well. But that time, it definitely pays out because it then empowers all teams to build super fast on top of that abstraction. Then there is tracking the adoption. Well, it's like imaginary thing on the right. So list of your services with list of stakeholders, track, talk to, check in on them, make sure that they're progressing through that introduction of all that observability stack, and you help them. Then there is metrics. So adoption is not just about, well, you know, like again, having a table and ticking boxes. It's about being properly data-driven and building those adoption metrics into your abstractions. So when somebody starts using that trace and you actually know about that, you know which language do they use, which version of that abstraction do they use in that particular service, so then you can actually have the full view of what's happening. And then iterate. You are most likely, same as me, are not going to get it right from the very first attempt. It's fine. It's learning, it's time, it's effort, it's experience. So if somebody tells you that this doesn't work, we need to do differently, talk to them and change, again, those abstractions, those standards. Come back to the drawing board, just do it over again. Again, track adoption, rely on metrics, get the feedback. You're going to get it right. Well, just 1 minute on how to sell shortly. So it's very important to find early adopter and working with them closely, as hands-on as possible, doing and piloting like first services yourself in that stack, so you have confidence in what you think is right, and then a team has confidence in what they think is right. It may be not a team, it may be like 1 or 2 people on that team. And then once you have that, then you have nice feedback from someone, and you have 1, 2, 3, several services working in production using that, and then you can show that value to everyone else, and that team are going to be your advocates. And then it's just going to spread, because there will be another team, there will be another team, and then eventually it will just going to work, and everyone is going to be happy because they will have that nice heart in the middle, and they will have that full observability. Thank you.